And now it's time for some quick fire multiple choice questions. So let's have a look at this example here, example 5.3. Students in 12B recorded the time spent studying and hours next to their test scores. The data is shown on a scatter plot below. The association between 12B test scores and time studying is non-linear. As we can see, there's a little curve forming here. In order to linearize the data, which of the following lists the correct options for data transformations? Well, this is literally just which one of those is the circle of transformations. That's clearly this shape here, so we just need to see y squared log x and 1 over x as one of the options. And there it is, C is our answer. We have got a table showing the speed in kilometers per hour and the braking distance in meters of a car traveling at 8 different speeds. The scatter plot has been constructed where speed is the explanatory variable and distance here is the response. The scatter plot shows the association between distance and speed is nonlinear. A squared transformation is applied to the variable speed. So what does that mean? That means we've had an x squared transformation. A least squares line is then fitted to the transformed data with distance as the response variable. So what we need to do is we need to go and see which ones that we can use. So for these ones here, what I would do before I do any hard work is I would actually go and eliminate anything that is unnecessary. Well, the only thing that's being squared here is speed, and it's the explanatory. So if there's speed in the response section, like those, nope. And so it's got to be one of those. As you can see, we've got 3 possible options here. We can quickly chuck this into a CAS, which would probably be the most sensible option. And then we're going to do an x squared transformation. So I'm going to list 1 squared. What I'm then going to do is going to do regression or set the graph. Actually, we don't need to set the graph. I just want the equation. I don't want to see it. I just want to see the equation. So linear reg. We've done an x squared transformation, so it's going to be a list 3, bang. So we need whichever one says 0.0918 or 0.092, and that is this friend here. This one's not multiple choice, but I'm sure we can fit it in. The time series data below shows the worldwide growth in electrical power generated by the wind. The variable that represents time in years has been rescaled, so 1 represents 2001, 2 represents 2002, and so on. This new variable is called year number. A time series plot has been shown. So just so you know about a time series plot, it's just a scatter plot, but they've connected all the lines together. A relationship between power and year number is clearly nonlinear. A log 10 transformation has been applied to the variable power. So that's here. So this is a log y transformation. Apply this transformation to the data to determine the equation of the least squares line that can use predict power. Write the values of the intercept and slope for this least squares line. We need 4 significant figures. So again, we're going to go into a CAS. So what are we doing? We're doing a log of the y. So I'm going to write log 10 and list 2. There we go. So they've all been logified, and we want to find the equation list 1, and the y list is list 3. Bang. So we've got here this log. So and do we have to write in symbols or words? Oh yeah, it says in the appropriate boxes below. Oops, I have not put any boxes there. We just need to write the those values here. So the intercept, which is the A, to 4 significant figures would be 4.287, because the first number significant there is the 4. For the slope, it's 0.0, and the first significant figure here is 9, so 990, in this case 2. There we go. Use the equation in part A to predict the electrical power in megawatts expected to be generated by wind in 20. Oh, so this time we have to predict the electrical power expected in 2020. So 2020, so if 2001 is number 1, then the 2020 is 20. So we're going to do log 10 power is equal to 4.287 plus 0.09902 times by 20. And you can pop that into your calculator, whichever one you wish to do. So just going to, okay, we'll go to menu, main, 4.287 plus 4.287 plus 0.09902 times 20. So it's going to be 6.2674. Now, before you write that as the answer, here's the trap. This is log 10 power. This is not the actual power in megawatts. We need to convert from the log to the actual amount here. You might remember this from chapter 1. If not, that's okay. If I've got log 10 of a particular number, then if I want the power, I just need to do 10 to the power of this number here. So 2674. So I just need to go 10 to the power of 6.2674. And this gets me, and we want to the nearest 1,000 megawatts. So 185. We're going to round it up to 1,000. There we go. So 1 million. Just want to make sure I've got my numbers here. 1,851,000, because I had to round up because there was a 9 there, megawatts. All right, the table shows the length in centimeters and widths of 8 sizes of sticky labels. And we're using a 1/y transformation. So let's get our data in for this one. And we're going to do a 1/y transformation. So we need to set that instruction. So we're going to go list 2. Oh, it's 1 over list 2. Because that was the 1/y transformation. The transformation, the y's were in list 2. We're going to linearize the data and fit a regression line to the transformed data. Length is the explanatory variable. Yeah, we'll do that. Write this equation. So linear reg, list 1, and we want list 3. In fact, what we'll do is we'll also set the graph as well so we can see what we've done. This one, list 3, calc, regression, linear reg, list 1, list 3. Okay, so our equation here, always these worded answers. So width is equal to, what do we got here? Width is equal to, oh, hang on, I nearly made a rookie mistake there. 1/width is equal to 0.0147 plus 0.0859 x. Oh, we need to have it in terms of length and width. All right, almost stuffed it up again. Length. So I fitted the regression line. There's my scatter plot, and we use the equation to predict the width of a sticky label with length of 5 centimeters. So 1/width is equal to 0.0147 plus 0.0859 times 5. So we can pop that into our calculator, which is all lovely. Times 5, which gets me 0.4442. Now, of course, that's 1/width. So if I want the width, then I just need to do 1/0.4442. 2. I just need to do the opposite. So all I have to do is 1 over, and there's a little ants button there, and I get there 2.25. An alternative way you could have done this is, if you didn't want to remember that, is that if you just go and press solve. So if you go to math 3 and go to solve and do 1 over y equals 0.0147 plus 0.0859 times 5 comma y, that can also solve that for you quite easily.